Hello everyone, welcome to Wings of Physics. Myself Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. We will continue our topic Electrostatics, and today's lecture is lecture number 2. In this lecture, we will study the application of a Gausslaw, second application and third application of a Gausslaw, and the second application is electric field intensity due to infinitely long straight charge wire. Consider this is a infinitely, though it is a finite, it is infinitely long straight and charge wire, means a charge is supplied to that wire, and we know that if length is there, then the linear charge density is there, and it is denoted by term lambda, that is Q divided by L, and therefore charge Q that is equal to lambda into L. Understood? This is equation number 1, and lambda is the linear charge density of this infinitely long straight charged wire, and we have to find out electric intensity outside this wire, and for that purpose we have to consider a Gaussian surface, and this is, suppose this is a Gaussian surface, means the electric intensity at this point, at this point, at this point are the same, and here also at this point, at this point, at this point it's same, means the Gaussian surface that is nothing but a coaxial cylinder. This Gaussian surface that is a coaxial cylinder, it is having radius small r, and L is the length of that Gaussian surface. Understood? And we have to find out intensity at a point P, and at point P ds is the small area is there, and ds vector, this ds vector means area vector is in this direction, because we know that area vector that is always a perpendicular, area vector that is always a perpendicular, and if charge is positive, direction of electric intensity is away from the charge, means E and ds they are in the same direction, and therefore the angle between E and ds is 0 degree, and therefore cos theta that is equal to 1. Now consider the Gausslaw. What is the Gausslaw? Gausslaw is the phi electric flux over this closed surface, that is nothing but 1 by epsilon naught Q net, means charge enclosed. Then the, if epsilon naught is the permittivity of medium, then epsilon naught into K, and if that Gaussian surface is kept in a air medium, then K that is equal to 1, because dielectric constant for the air that is equal to 1, and therefore Q net charge enclosed that is nothing but the lambda L divided by epsilon naught. This is the equation number 1. Now we have to find out the flux by using another form of Gauss law. Then phi that is equal to surface integral of E into ds. Okay. Then the surface integral of product of magnitude of two vector, means E into ds into cos of theta. Then cos theta that is equal to 1, and therefore but E is the constant, and therefore E into surface integral of ds, and now we have to find out the surface integral of this ds. For that purpose, consider this is a Gaussian surface, and this Gaussian surface, this is the case. The wire is here, means this Gaussian surface that is a coaxial cylinder with this the wire, and there are the three surfaces. See, this is the surface, one surface, then the another surface. Suppose this is the one surface, then another surface, and this third surface. But what happened about this surface? In this case, the area vector is in this direction. and electric intensity is in this direction. Means out of this first surface, the theta is 90 degree for this surface. It is present in this manner. Then the flux on this surface, that is 0, because theta that is equal to 90 degree and cos 90 that is equal to 0, means there are no flux on this surface. Then under this second surface, this surface, in this case also area vector is in this direction, electric intensity is in this direction, they are also perpendicular, means flux on this area also not present, means flux is present on this cylinder only, and L is the length and small r that is the radius, means the surface integral of ds, that is nothing but the area of this Gaussian surface, means only this curved surface we have to consider. Suppose the L is the length, this is the case. If L is the length, this L is the length and r is the radius of this Gaussian cylinder, then the 2 pi r, that is the length, and this is the breadth, then area of this curved surface, means this is the curved surface, and area of this curved surface, that is nothing but 2 pi r into L. And if we substitute this area, it becomes E into 2 pi r into L, and this is equation number 2. Now equating equation 1 and 2, we can find the intensity at a distance small r. Okay, and equating these two equations, lambda L divided by epsilon naught, that is equal to E into 2 pi r L. Then LL that gets cancelled, and value of electric intensity, that is equal to the 1 by 2 pi epsilon naught, then lambda divided by r. This is the value of electric intensity at a distance r from this, the axis of the wire. Okay, we can write this formula one another form. If we multiply and divide this equation by 2, this equation becomes 1 by 4 pi epsilon naught 2 lambda divided by r, and we can use this second formula to calculate the electric intensity, and this 1 by 4 pi epsilon naught, that is Coulomb's constant, and its value is 9 into 10 raised to 9 Newton meter square per Coulomb square. This value is useful for solving the problem. Okay, now we will study the third application of a Gauss law. Today we will study the third application of a Gauss law, that is electric field due to a charged infinite plane sheet. Now consider, this is a charged infinite a plane sheet, and a sigma is the surface charge density of this sheet. Means sigma, that is equal to charge per unit area. We already studied that. The surface charge density, that is charge per unit area, means the sigma, that is equal to charge per unit area of a sheet. Though this is a finite sheet, but we have to consider a very large infinite plane sheet, and sigma is the surface charge density of this sheet. Now we have to find out electric intensity due to that sheet. Suppose we have to find out the intensity at distance r. Now the intensity is present on both the side. Suppose at distance r, and for this purpose we consider a Gaussian surface, and that Gaussian surface, that should be symmetrical, and for that purpose consider this Gaussian surface. This is a Gaussian surface, and consider the 2 points, P points and point P dash, and they are at a distance R and R from this sheet. Okay, and we have to find out electric intensity at a distance R from this side and at distance R from this side. Okay, then the surface area of this side, that is the A. A is the cross sectional area, and also A is the cross sectional area, and the charge enclosed in this section. Consider this figure, and charge enclosed in this area, that is also area A. And now we have to find out electric intensity. For that purpose, we have to use a Gauss law. What is the Gauss law? The electric flux over a closed surface means the electric flux over the closed surface, that is nothing but the 1 by epsilon naught times the net charge enclosed in this surface. Now we have to consider the charge enclosed in this surface, and that is from this equation, the charge enclosed, that is equal to sigma into A, and therefore the Q divided by epsilon naught, that is nothing but sigma A divided by epsilon naught, because we consider the medium is air, because we know that epsilon naught is the permittivity of medium. Epsilon, that is nothing but epsilon naught into K, and for air medium K, that is equal to 1, and if we place this sheet in a air medium, at that time K, that is equal to 1, and therefore permittivity of medium, that is nothing but the epsilon naught, and this is equation number 1. Okay. Now we have to find out flux. For that purpose, for that purpose we know the formula. What is the formula? Surface integral of E into ds at point P, and plus surface integral of E into ds at point P dash. Okay. Then the area vector, that is always perpendicular to this surface, and the sheet is positively charged, means the electric intensity is in this direction, means vector E and vector ds, means area vector and electric intensity, they are in the same direction, and therefore theta, that is equal to 0 degree, and theta, that is equal to 0 degree, therefore cos of theta, that is equal to 1, and therefore the surface integral of E into ds into cos theta at P. Again, surface integral of E into ds into cos theta at P dash. Now substitute this theta, that is equal to 1, and therefore it becomes E ds only at P and E ds at P dash. Okay. Now this ds area, that is nothing but the A. A is the area of cross section, and therefore E into A, because surface integral of ds, that is considered as a area A, plus here also E into A, that is nothing but 2 into EA. This is the flux. Now equating equation 1 and 2, we can write the sigma A divided by epsilon naught, that is equal to twice E into A. Now this AA, that gets cancelled, and therefore intensity E, that is equal to the sigma divided by twice epsilon naught, and by using this formula we can calculate the electric intensity due to the charged infinite plane sheet. Okay. And from this formula it is clear that there is a R term is absent in this equation, and therefore we can say that this intensity, it does not depend on the distance, because the distance is very small compared to this area of this sheet, because sheet is very large and infinite sheet, and therefore this intensity, that does not depend on the distance R. Understood? Are you getting my point? And in this manner, we can calculate the electric field due to a charge infinite plane sheet. Okay? If you like this video, then like, share and subscribe my channel, and also press the bell icon to get notified about my new upcoming videos. Thank you.